Okay guys, this is a little video to explain binary numbers, okay? Now, let's just explain what a binary number is. A binary number is comprised of just zeros and ones, okay? Now computers, they only see zeros and ones. So everything that you put into a computer, whether it's the letter A, capital A, or whether it's music, or whether it's text or video, that computer just sees it as a series of zeros and ones. All right, when we have a choice of only two things, like 0 and 1, we call that binary logic, okay? So computers see binary numbers, numbers that are just made up of a series of zeros and ones, okay? Now, each one or each zero that the computer sees is known as a bit. And if you look at this table down here that I have here, it has 8 columns. 1, 2, 3, 4, 5, 6, 7, 8 columns. Okay. Now, if I have 8 bits, that equals 1 byte. Okay. 1 byte, or 8 bits, so 1 byte is just enough memory to store 1 character of the alphabet. Okay? So, in order for my computer to see a letter of the alphabet, like A, okay, it is comprised of a binary number that has 8 bits, or 1 byte, okay? Now, there's something that is known as the American Standard Code for Information Interchange, or ASCII, okay? ASCII is a code that translates letters into numbers. And in fact, ASCII has a whole bunch of codes for all sorts of different types of things, whether it's colors, video, text, pictures, whatever it is, okay? For our purposes, okay, we're just going to deal with letters. So this is the ASCII code for all of the capital letters of the alphabet. I'm going to give you the ASCII code for all of the lowercase numbers of the alphabet as well. I'll show you that to you a little later on. But for now, we're just going to deal with capital letters, okay? So let's imagine that we want to change the letter F into something that the computer can understand, okay? So I look here on my ASCII code chart, and the letter F is represented by the number 70, okay? Now I have to translate that number 70 into a binary number, okay? Now I can use my bit table right here to convert that 70 into a binary number that the computer will understand. All right, so once again, the letter F in ASCII code, that is the number 70. So I want to convert the number 70 into a binary number that the computer can understand, okay? So the way we do that is we start over here on the left-hand side, the furthest table, okay? So is 70 bigger than 128? No, 70 is less than 128. So I put a 0 there, okay? Is 70 bigger than 64? Okay. Yes, it is, okay? So 70 is bigger than 64. So I put a 1 in there, okay? So now I do a little bit of math. 70 minus 64 equals, where's my equal sign? 70 minus, oops, not plus. 70 minus 64 equals 6, okay? So is 6 bigger than 32? No. So I put a 0 there, okay? Is 6 bigger than 16? No, I put a 0 there, okay? Is 6 bigger than 8? No, so I put a 0 there. Sorry guys, I'm just gonna get Krusty, my dog, because I think he's gonna start barking. Oops, okay? So, is 6 bigger than 4? Yes, it is. Okay, so I put a 1 there. So now I just do 6 minus 4 equals 2. Okay? Well, 2 equals 2, so I put a 1 there. Okay? 2 minus 2 equals 0, so I've got nothing left. So in the last column, I put a 0. So I've got this number here, this binary number. Okay? This binary number of 0, 1, 0, 0, 0, 1, 1, 0. Okay? That binary number equals that ASCII number of 70. Okay? So 0, 1, 0, 0, 0, 1, 1, 0 in binary equals the ASCII number of 70. Okay, and as we can see here, the 70 is code for F. Okay, so you type an F into your computer, and the computer sees this number here. Okay, 0, 1, 0, 0, 0, 1, 1, 0. Okay, so that's how we translate a letter into a number and translate that number into a binary number. Okay, now in class I gave you guys a homework sheet. Okay, let me find that sheet. Where is it? Yes, so this is the sheet. You're going to convert these letters into binary numbers just like I just did. So there's a capital A, there's lowercase f, capital C, lowercase p. Okay, now I'm also giving you guys a calculator, binary calculator. Okay, so if you open up the first sheet of the calculator here, I'll show you how to use this in class. Don't worry for that now if you can't make it into class. What you need to know though is here's the ASCII codes. Okay, in other words, here are the numbers for the lowercase letters here. And if I scroll up, all of these here are the all of these are the numbers for the uppercase letters. Okay, so try doing that at home following this video. Okay, and convert these letters into binary numbers down here. Okay, and if you're skilled with that, try using your binary calculator, okay, to convert these binary numbers into letters. And the way you do that is you put that number, okay, put these numbers into your binary calculator. So I go back into the calculator, okay, and if I look here, oops, so I'm going to make that smaller so I can see everything. Okay, so for example, first number here is 0, 1, 0, 0, 1, 0, 0. Okay, so it's a binary number of 0, 1, 0, 0, oops, 0, 0, 1, 0, oops, 0, 1. Okay? So I can see here that that binary number is an ASCII number of 73, which is the letter I. Okay? So I put a I over that, and I would do the same with this, and there's a message encoded there, and you guys can figure that out using your calculator. All right, your binary calculator. All right, see you guys in class.